All right, this video is going to be over the properties of quadrilaterals and parallelograms and using them to solve some problems. First thing we're going to talk about is these quadrilaterals. Quadrilaterals, there are only two characteristics of these. Their angles are going to add up to 360 degrees. Okay, and when we looked at angles of polygons in our classes, we saw that four-sided figures, angles all add up to 360 degrees. This will be every single quadrilateral we talk about. And as in the name quad, the figures are all going to have four sides. So looking at the flow chart that we have, quadrilaterals is all the way at the top. Okay, we got four sides and interior angles add to 360 degrees. Now, we're going to naming quadrilaterals. We have four letters. We're going to use the four letters, the vertices. There are 8 different ways that you can name this quadrilateral, but I'm not going to name all of them. We're just going to cover a couple in and how you're going to do it. In order to name a quadrilateral, you need to start off with any vertex. So let's say we start off with A. Then you need to go consecutively in counterclockwise or clockwise order, naming the other three. So here we could say as easy as A, B, D, C. Okay, so A, B, D, C is one. We cannot call it A, B, C, D. You cannot cross through. You have to go around the perimeter. We can name it D, C, A, B. And let's check out one that's going counterclockwise. B, A, C, D. And then let's do another counterclockwise. D, B, A, C. Oops. D. Started with D. C, B, A, C. Sorry for the sloppiness. All right. So let's go ahead and start looking at some of these characteristics, these properties, and solving for some problems. We want to know out of A, B, and C, which one are the quadrilaterals. So, well, let's take a look at C real quick. We got 5 sides. So this is not a quadrilateral because we have 5 sides. We're putting the reason why they're not also. Now, if we look at A, let's take a look at this and let's add all the sides, the angles up together. If we do 90 plus 90 plus 70 plus 70 and we add all of these together, we're going to wind up with 320 degrees. Remember, property number 1 up here, all angles add up to 360 degrees. This is 320, so this is not a quadrilateral. Okay, so not equal to 360 degrees. If we take a look at B, you could probably figure out what's going to happen here. If we take all 4 of these, 60 plus 120, I don't know why I did that way. Clean that up a little bit. 60 plus 120 plus the other 120 and the other 60. Kind of did that out of order. We have 2 120s and 260s. This will add up to a total of 360 degrees. So this one right here is going to be our quadrilateral. So the next two we're going to solve for the missing angle using the fact that all angles add to 360. Okay, so angles add to 360 degrees. So using our algebra here, we can do, 90 plus 90 plus the 70 plus x, running out of room here, sorry, equals 360 degrees. When we combine our like terms, 90 plus 90 plus 70, I'm going to move my x over here. We're going to have x plus 250 is equal to 360. All I did was add 90 plus 90 plus 70, got 250. And now, as we know, whenever we solve for x, subtract that 250 from both sides. We're going to find out that x, our missing angle, is going to come out to 110 degrees. So it's just a matter of adding all 4 sides to equal 360. And we're going to do the exact same thing over here. It's just this time we have an x plus 20. No big deal. Let's take that x plus 20, so I have my x first, plus this 47, plus the 100, plus that last 60. So we have all 4 sides all equal to 360 degrees. We've got a single x. Let's go ahead and add up our constants. 20 plus 47 plus 100 plus 60. We add these together. We're going to end up with 227, all equal to that 360 degrees. Okay, in this case, same thing we did earlier. Subtract that 227 from both sides. x is going to be equal to 133. Now we did want us to find the missing angle. Well, the missing angle was equal to x plus 20, so we need to substitute in for x. X is 133 plus 20, so that your actual missing angle here is going to be 153 degrees. So I'm going to mistake that degree as a 0. We have a degrees. All right. Let's go ahead and move on. Please pause and rewind if we need to. Let's talk about parallelograms. Parallelograms, I'm going to start with number 6. Number 6 is showing us here that we have all the properties of a quadrilateral. They're still existing, which are just the two that we just talked about, 360 degrees for their angles and 4 sides. We have a few extra. One, our opposite angles are congruent. So over here with this first one, let's go ahead and show that your opposite angles are congruent, and then these two right here will be congruent. They're not all 4 congruent. Not yet. We have our opposite sides are congruent. So over here, we'll say the opposite sides, these two are congruent, and right here, these two are congruent. Next, we have opposite sides are parallel. Remembering what our parallel symbols mean, or what they look like, they're either going to be arrows like this, or you may see triangles. These two are parallel, and then right here, these two sides will be parallel. Just like with congruency, we need to add an additional marking there. Next, number 4, we're seeing that consecutive angles are supplementary. Consecutive is one after another. So if this top left one is 110, supplementary, remembering, is 180 degrees. That means the consecutive, the one right after it, has to be 70. Well, if you continue with consecutive, this is 70, this other one has to be 110. And if this is 110, then the next one has to be 70, which also satisfies property number 1, where opposite angles are going to be congruent. The last one is that the diagonals will bisect each other. So we draw in our diagonals here. Each one is going to be cut into 2 congruent sections. Again, adding that second congruency on the second diagonal. They're not all 4 the same. Okay? So let's take a look at some of these in action. Number 1, we want to find the value of x. Okay? So x, we need to see here, remembering that our opposite sides are congruent. So all you have to do, we're going to go ahead and put in here what our properties are. Opposite sides are congruent. So x is simply equal to 12, telling us that the measurement of AD, right here, these are going to be congruent. So the measurement of AD is going to be equal to the measurement of CB as well. So not only are AB and DC going to have the same measurement, but AD and BC will have the same measurement as well. We take a look at number 2. We want to find x. Well, x is an angle right here. And we remember from property number 1 up top, your opposite angles are congruent. So here we can mention our property, opposite angles are congruent. So x is simply going to be 70 degrees. Then they want us to find the measurement of angle DAB. Well, using our consecutive angles, or supplementary, we just take that 180 from supplementary, subtract that 70. I'm sorry, this one's saying congruent too. I am jumping ahead here. Well, hey, now you know how to solve it. If we just subtracted from 180. The angle, angle DAB will be congruent to angle BCD. Just asking for a congruency statement. My bad. All right, number 3. Here we're going to solve for x and for y. Well, for x, let's take a look at solving for x. X is dealing with segment AB. Well, remembering that our opposite sides, this is going to be for both of them, I'll tell you that right now. Opposite sides are congruent. AB will be congruent to, well, we got to put 2 tick marks, I got these. AB will be congruent to DC. So all we have to do is take that 2x plus 8, set it equal to its opposite side of 12. Okay, and I'll go through this real quickly because it's only 2 steps. We're going to subtract that 8. We're going to get 2x is equal to 4. Now I'm just going to use the same color. Divide by 2. X is going to be equal to 2. Now we take a look at solving for y. Again, opposite sides being congruent, we're just going to set the y plus 3 equal to 15, and we only have 1 step to take here. Subtract that 3. Y equals 12. So we have a lot of congruency going on here. Just set them equal to each other. All right, number 4, we are going to find x and y. For x, we need to remember that opposite angles are congruent. Okay, because x is right here in angle B, and angle D, its opposite angle, has a measurement. So we set them equal to each other. Okay, so here we have 2x equals 50. A simple divide both sides by 2. X is going to end up equaling 25. Now for y, we need to remember that consecutive angles are supplementary. So here, all we have to do is take that 180, subtract its consecutive angle. Angle D and angle C are consecutive. That means both of these added together equals 180. So if we just subtract that 50 from 180, we're going to get 130 degrees. Guys, using these properties, starting to get used to that. All right, we have 4 steps to take on number 5. We need to solve for v, x, y, and z. So let's see what we can start off with. Well, x is an old property we've learned before, right here. So solving for x, we need to see here that we have a linear pair. Okay? So with a linear pair, we just take that 180, subtract the 71, and we're going to wind up with 109 degrees. So we're not going in order here, and that's okay. I'm just looking at what can I find real quick. Okay? Now, let's take a look at z. Let's take a look at z. Down here, what I want to do is I want to take a look at the fact that we have a triangle right here. We can use our triangle sum theorem and add all 3 angles to equal the 180. We have the 42. We can find this because opposite angles are, sorry, let me rewind. We have vertical angles right here, 6, and over here, this angle we're missing are exactly the same. X and, well, x was 109, so this is going to be 109 degrees. Or you can look at another linear pair right here. So this guy right here is 109 degrees. So we're going to take our 109 plus the 42 to get 151, and then subtract that from 180, and we get 29. So all the way down here at z, we've got 29. All right. So here we got, I'm going to label that 29 just in case we need it. Now, finding v and finding y. We need to check out a couple things here. Let's look at v first. Okay. We need to remember over here, where'd v go? V's right here. Okay, just this angle. Okay. What we need to remember is that our opposite sides are parallel. Okay, write in parallel if you need to. So what ends up happening is with our opposite sides parallel, segment DB, what I need you to understand, is acting as a transversal. Okay, it's been a while since our class have talked about that, since first semester. But your transversal going through parallel lines is going to create alternate interior angles. So what that means is over here, angle ADB, where V is, and angle CBD, where the 42 is, are congruent. So for V, all we have to do is set that 2V plus 3 is equal to 42. And I've told my students, things we talk about in geometry do not stop. We're going to keep seeing them. So let's quickly subtract that 3. We're going to get 2v equals 39. Sorry, yep, 39. We divide by 2 on both sides. We're going to see here, we're going to end up with a decimal of 19.5. Now the last one we need to find is going to be y, my bad. Y right here. Again, using the same property, we have alternate interior angles, okay, because these sides are parallel as well. Actually, we're using the same two parallel sides. So alternate interior angles using segment AC as that transversal. We're on alternate sides. And we're interior, alternate interior angles that are congruent. So y will be congruent to this angle over here of 38. You're going to have to remember these. I know this one may have seemed a little overwhelming, but please ask your teachers for help if you need any. Okay?